Question 15, and this shows that our examiners can do their stuff when they have to. A perfect question, tests the syllabus, and there doesn't seem to be anything wrong with it. I'm sure the kids went well in it. Really, it probably could have been a little bit earlier in the paper. Anyhow, let's go. The graph shows a network, and we can see it's a directed network. There's flows going through. The numbers on the edges indicate number of liters per minute that can flow along the pipes. And it's a nice simple little flow network here. So part A, show the value of X, which is we've got a cut through here, and the value of the cut is 57. So we know that X, we ignore the 6 because you can see the flow from A to B is going from the sink to the source. So we ignore that flow, but we know that X plus the cut here of 19 rather, must be 57. So here's our equation. X, the mystery number, plus nothing, we ignore this one, plus the 19 for this cut must be 57. Therefore, X is 38. 57 take 19. So, part B here. Calculate the value of the maximum flow through the network. So, a couple of ways of doing this. We could sort of systematically work through, but if we stick to cuts, we've got a cut here. I've put in that X is 38. We've got a cut here of 63. At the sink, we've got a cut of 56. The cut that we were given through there was 57, and there's a cut down through here of 53. And if you look anywhere else, if we didn't cut through the 22, we'd have to go through the 34, which we've done is 56 and it's bigger. And over here, the 6 and 25 are bigger than the 19, so it's not going to help coming through here. So the maximum flow is 53 liters per minute, using the minimum cut maximum flow theorem. And then on the diagram below, we've got to show the possible flow along each pipe. Now, there's quite a few ways, but we'd start here by taking the ones on the maximum flow minimum cut here. We know that all of those pipes are flat out. So we can put in the 22 and the 12 and then the 19 down here. Then we know that the flow in must equal the flow out at any vertex, so that here 12 and 19 gives us 31 coming up through here. And over at the beginning, because we need 19 coming in here, there's several ways we could have done it, but I've just bunged a 0 down on this arc and 19 across there, so that we've got 19 plus 0 add up to 19. And that means we need 34 going up there to add up to give us the 34 that comes out the other side of A. Lots of other ways, though, of doing this early bit. So that's basically up to you, but I chose the easy way. Then on to the next page. Extra pipes are added to form a new system. So you can see here was the old diagram, and here is the new one. So on the new diagram, we've got these 3 pipes have been added down here. So here's the old one with the flow this is basically a copy of the previous question, or part of the question. And so if we kind of subtract the flow that's going through these, we've got none left here, none left there, none left there. We've got 31 coming up here, so that leaves us 3 spare up here. And up here, we're sending 34, so we've got 4 left. We've still got room for 6 down here and 6 across here. So how much extra can we get through? So what I'm looking at is coming into the sink at T, we had room for 3, but now we've got this extra edge, which is bringing in 6. So that's a possibility of 9, so long as we can get that 9 to these. So the 3 here could obviously flow up here because we've got a capacity of 8. So that 3 is accounted for. And this 6, so we've got 3 and 6. And obviously this 13 can split and send 3 up that way and 6, and we've still got some spare. So that's looking good. We've just got to check, can we get this extra 9 to B? And obviously we can. We could send 6 directly from S to B and the other 3 up around this route. So a little bit of back checking there, and we can see that we can actually increase the new flow of the system by 9 liters per minute. So if we add it to the existing 53 that we had, then we're going to get an increase up to 62 liters per minute.